In question 4, we want to start by isolating the radical, just as we did in the first two problems on the first page of the note sheet. So we'll begin by adding 3 to each side. This tells us that the square root of x plus 2 is equal to 2x plus 3. Now we've isolated the radical, but now we're trying to isolate x. So we need to use the inverse operation for taking a square root, which would be to square each side. On the left, that peels off that radical, and on the right, we need to remember to properly square a trinomial, which in this case will give us 4x squared plus 12x plus 9. Now we realize we have a quadratic equation, and we spent all of Unit 4 solving quadratic equations, so we know that we need one side to equal 0. Subtracting the x and the 2 from each side gives us that 4x squared plus 11x plus 7 is the quadratic that we're trying to solve. So we know we always have a preference for solving by factoring. So let's see, is there something that multiplies to make 28 and adds to make 11? I'm thinking 4 and 7 should do that trick. So 0 is equal to 4x squared plus 4x plus 7x plus 7. And when we factor this, we can see the first two have in common a 4x, leaving x plus 1, and the last two have a positive 7, also leaving an x plus 1. That allows us to take the x plus 1 that they have in common times the other factor, 4x plus 7, and that's set equal to 0. Setting each of those factors equal to 0, we see that x could equal negative 1, or in the other case, since 4x plus 7 would equal 0, 4x could equal negative 7 and x equals negative 7/4. Now remember, we always have to check our results to see if there are any extraneous solutions. And when we do that, we need to make sure to go back into the original question. Let's start with the easier one. We have the square root of negative 1 plus 2 minus 3, and we're wondering, does that equal 2 times negative 1? Well, the square root of negative 1 plus 2 is really just the square root of 1, and the square root of 1 is just 1, so 1 minus 3 is a negative 2. That does equal the negative 2 that we would get when we multiply, so we can circle that answer. For the negative 7/4, we're going to have to work a little bit harder to check, so we'll take a look and put in that negative 7/4. So we have the square root of negative 7/4. Now instead of writing plus 2, I would write plus 8/4 so that I'm getting that common denominator, minus 3, and then we're wondering, does that equal 2 times negative 7/4? Well, negative 7/4 plus 8/4 would be 1/4, and the square root of 1/4 is 1/2. So instead of minus 3, we'll say minus 6/2. Sorry, don't know why I wrote a 3. So this is negative 5/2. Now when we go to simplify on the other side, the 2 on the top and the 4 on the bottom give us a 2 on the bottom when we reduce. And that negative 7/2 is not equal to negative 5/2. So we want to label this solution as extraneous, and we will not circle it, because if we're circling it, then we're sending mixed messages and kind of suggesting that there's two solutions when there's only one.